block diagram representation of discrete time system. In this process, we'll be using these three operations, that is adder, gain multiplier, and delay element. Already the block diagram representation, we have seen it for continuous time system with help of the Laplace transform. Now, with the help of Z transform, okay, the similar the representation we'll be studying for the discrete time system. First, adder. Suppose if you have more than one signal, okay, input signal or output signal, that can be added with the adder. Okay, again, we can also use we can also do the subtraction also using that. So that's why we can put wherever that minus sign is necessary, we can put minus sign. Okay, if we need adding operation, we can put the positive sign. The next, gain multiplier, that means input is multiplied by the factor of a. Again, the value of a could be anything, that means it can be greater than 1 or it can be less than 1. Next, delay element. Suppose if input is x of n, okay, then if you are applying the delay operation, okay, the delay operation is z inverse. Okay, in the z domain, that is simply z inverse, but in time domain it is delayed by unit 1, that is x of n will be delayed by unit 1, that is x of n minus 1, that is the output. Or otherwise, if you want to represent in z domain, that means x of z will be simply multiplied with z inverse. Okay, so that we'll get y of z. That means what, in time domain the x of n is delayed. Okay, now we'll solve the problem based on this. Draw the direct form, cascade, and parallel form block diagram of the following system function. The basics of direct form and cascade form and parallel form we have already discussed for continuous time system. The same thing, same basics will be using here also, but here instead of s we'll be operating with z inverse. And then in direct form itself, we are having two format, that is direct form 1 structure and direct form 2 structure, like direct form 1 and direct form 2. Okay, again, in case of direct form 1, we will be using different element. That means again in this case it is delay operator. Okay, so we'll be using different delay operator in both input and output, that is separately. In case of direct form 2, we'll be using a common delay operator. Okay, that is common to both input and output. Okay, again in case of continuous time system, it was like an integrator. Okay, there we'll be using 1 by s. Okay, both on input and output side. Okay, but whereas for a direct form 2, we'll be using common integrator for both input and out. Okay, so again now we'll be using here, now we'll be using only a direct form 1 structure. Okay, and also wherever necessary, we'll be using the basics of control system. That means what, whenever the closed loop block diagram is there, that output divided by input. Okay, output divided by input is the closed loop transfer function, that is g by 1 plus gh. Okay, if it is negative feedback, that is g by 1 plus gh. If it is positive feedback, that is g divided by 1 minus gh. Okay, see why? Because suppose if I'm getting function like this, for example, only this function 1 by 1 plus 1 by 2 z inverse, that means what, this is like negative feedback, so that I will be realizing like this. Okay, so the gain is 1. Okay, the numerator is 1. Then it delay operation again multiplied with the factor 1 by 2, that means negative. Okay, so minus 1 by 2. Okay, because it is negative feedback, then I am combining like this. Okay, either I can put a plus 1 by 2 here, then that means again I have to put minus here. Okay, no problem, all are same one. Okay, so again mostly direct form 1 structure. Okay, we'll be using some technique that ultimately it will lead to this format only. So whenever we are going for cascade and parallel form and all, we'll be getting smaller functions. That time we'll try to use the basics of control system, but You also try to know that how to utilize the direct form there. Okay. First, we'll start with direct form 1. Okay, so h of z we can write like y of z divided by x of z is equal to 1 by, just to multiply these two factors. Okay, 1 plus 1 by 2 z inverse minus 1 by 4 z inverse minus 1 by 2 z power minus 2. This we can write like 1 plus 1 by 4 z inverse minus 1 by 8 z power minus 2. Just cross multiply this y of z and x of z. Okay, so we'll be getting y of z plus 1 by 4 z inverse y of z minus 1 by 8 z power minus 2 y of z is equal to x of z. We know that for direct form 1 structure, okay, whenever it is in this format, we'll be assigning some new variable, that is w of s, w of z. Okay, then take the input function and output function separately. First, with the input function, that is x of z is equal to w z. Okay, so we can represent this like x of z multiplied with 1 is w of z. Okay, it's like temporarily we are using w of z. Okay, then what about at the output side? At the output side, we have to use y of z terms and also with w of z. So that is y of z plus 1 by 4 z inverse y of z minus 1 by 8 z power minus 2 y of z is equal to w of z. Okay. Ultimately, we are going to realize y of z, that is y of z is equal to w of z minus 1 by 4 z inverse y of z plus 1 by 8 z power minus 2. Okay, so now suppose if we have w of z, then from that we can get y of z. Again, the other terms are there with respect to y of z. Okay, so that we'll tap from here. The first term is with the delay, one delay, that is z inverse. Again, the gain factor is minus 1 by 4. And then the other term is with the 2 delay. Already one delay is there. Okay, so one more delay I'm applying, so that I will get z power minus 2. Again, the gain factor is 1 by 8. Okay, so now you can combine these two, then you bring here. Again, w of z is added with this term, so that put one more adder here. Okay, so add everything, then finally we'll get y of z. So now we have to combine the input side diagram and the output side diagram. So finally we'll be getting like this: x of z. Again, if you observe here that w of z is like a temporary variable that we have used to for the realization of direct form 1 structure. Okay, so now once if you combine these two, it looks like this. Okay, so this is the direct form 1 realization for the given function. Again, in this case, in the input side, we are not explicitly getting this z inverse term, that delay term. It's because in the question itself, they have not applied any delay operation. Okay, once if you expand, once if you bring that h of z to this format, okay, we are not getting any delay operation for x of z. In some problem, we may get the delay operation. According to that, we'll be getting delay operation at the input side. But in this case, there is no delay operation. That's why there is no z inverse term at the input side. Okay. The next realization of cascade form. Okay. So what is given h of z is equal to 1 plus 1 by 2 z inverse 1 minus 4 z inverse. We know that cascade means the output of one system will be connected to the input of the next system. Okay, so that means h of z, we can write like h1 of z simply multiplied with h2 of z. That means what, we can split up the system. Okay, the overall system we can split up as a two system and then implement those systems separately, then you just connect that system. Okay, so this is input x of z, is out. Okay, again, the output of the first system, say for example y1 of z, is given as input to the second system, that is say for example x2 of z. But remember that x2 of z, that means input to the second system is same as the output of the first system. Okay, so we'll separately we'll realize h1 of z and h2 of z, then simply connect those together. Okay, so from this, what is h1? Okay, h1 of z, we can take like okay, so h1 of z, simply we can take 1 plus 1 by 2 z inverse, and then h2 of z is equal to 1 minus 1 by 4 z inverse. Okay, so h1 is z, h1 is z is equal to 1 plus 1 by 2 z inverse, h2 z is equal to 1 minus 1 by 4 z inverse. Okay, so now we can use the concept of control system. Okay, how can we realize this? Gain 1 and then apply the delay. Again, we can put minus here so that it's a negative feedback. Okay, again, this is x of z, this is y1 of z. Okay, here it is positive feedback, so we can realize like this. This is overall output, that is y of z, because the output of the second system is the overall output, so I am writing y of z here. Apply the delay. Again, it is the positive feedback, so plus 1 by 4. Okay, then this is x2 of z, but that is same as y1 of z, so that now we have to connect these two systems together. Finally, okay, so this is the cascade form realization of the given system. Okay, if you are not comfortable with this, again here also you can apply the direct form one structure separately, then you'll get this diagram only, then again you can combine together. Okay, next one, parallel form structure. In case of parallel form, suppose if there are two system h1 of z and h2 of z, then For both the system, the input will be common, that is x of z. Okay, again, same input is given, x of z is given to both system 1 and system 2. But depending on the system transfer function, it will be producing different output, y1 of z and y2 of z, even though the input is same, but the system transfer function is different. That's why the output is different. Again, we have to combine these two, and finally we'll be getting y of z. Okay, so again, you suppose if the system is connected in parallel format, that means what? The input is common to both the system, then output is combined together. Okay, so again, you can write if you observe here carefully. Okay, what is y1 of z? Y1 of z is equal to x of z, h1 of z. Y2 of z is equal to x of z, h2 of z. Then y of z is y1 of z plus y2 of z. Okay, if you add these two, okay, again x of z is common, then h1 of z plus h2 of z. Okay, so this thing we can write like x of z, then multiplied with common h of z. That means what? The combined together, I can put like h of z. Okay, h of z. Again, the input is x of z, output is y of z. Okay, so now we are given with h of z. So again, we have to split up into h1 of z and h2 of z, then implement it separately, then give the connection like this. Okay, so then what is the given h of s? How to split up? Okay, how to split up? So from h of z, from h of z, we have to realize h1 of z and h2 of z separately with the addition, so that we can do easily with the partial fraction technique. So h of z is equal to 1 by 1 plus 2 z inverse 1 minus 4 z inverse. We know that the partial fraction a by 1 plus 1 by 2 z inverse, then b by 1 minus 1 by 4 z inverse. Okay, just apply the partial fraction. I'm writing the result directly. A value is 2 by 3, 1 plus 1 by 2 z inverse. B value is 1 by 3, 1 minus 4 z inverse. Okay, again now we have h1 of z and h2 of z. Okay, what is h1 of z is equal to 2 by 3, 1 plus 1 by 2 z inverse. Okay, how to realize this h1 of z? Very simple. Again, use the concept of control system, that is g by 1 plus gh. Okay, so the gain is 2 by 3, apply the delay, then factor is minus 1 by 2, gain factor is minus 1 by 2, then you add here. Okay, so this is the realization of h1 of z. Okay, okay, x of z is the input, then y1 of z is the output. Then how to realize the second function, that is h2 of z? h2 of z is equal to 1 by 3 divided by 1 minus 1 by 4 z inverse. 1 by 3 z inverse. Now in this case, this is plus 1 by 4. Okay, it's like positive feedback. Now this is again same input, but the output is different, y2 of z. Okay, so now we have to combine these together. Okay, if you observe where the input is same, in both the cases input is same, output is different. Again, we have to add the output together. Okay, so once if we combine both the diagram, 2 by 3, same input. In this one, that is 1 by 3. This is y1 of z. This is y2 of z. Then combine together, that will get y of z. Next question. Draw the direct form realization of y of n is equal to 1 by 2 y n minus 1 minus 1 by 4 y n minus 2 plus x of n plus x of n minus 1. In this case, they are asking direct form, only direct form. So that we'll try to realize in both direct form 1 as well as in direct form 2 structure. Okay, first direct form 1 format. First take the z transform on both sides. Y of z is equal to 1 by 2 z inverse y of z minus 1 by 4 z power minus 2 y of z plus x of z plus z inverse x of z. Okay, then bring this term y of z terms to the left side. If from the left hand side take the y of z outside, from the right hand side take the x of z outside. Okay, from this we can calculate what is y of z divided by x of z. Y of z divided by x of z is equal to 1 plus z inverse Okay, so now again for realization of the direct form 1 structure, okay, we can operate from this step itself. Say for example, this is the equation 1. From the equation 1 itself, we can operate for direct form 1 structure. But this term will be useful for direct form 2 structure. So now to operate with the direct form 1, okay, we'll take this equation. Y of z minus 1 by 2 z inverse y of z plus 1 by 4 z power minus 2 y of z is equal to x of z plus z inverse x of z. Again, we'll assign this with the new variable, that is w of z. Okay, first we'll realize the input side. Okay, x of that is w of z. Okay, input side, that is w of z is equal to x of z plus z inverse x of z. So that means what? Suppose if we have x of z, okay, from that we can get w of z. Okay, then again it is also delayed again with the gain of 1. Then again you add this here. Okay, this is with the gain 1. So now we are having for w of z, we are having x of z as well as x of z delayed with z inverse. So this is the realization at the input side. Okay, again for the realization at the output side, we'll take y of z and w of z term. Okay, at the output side. Okay, y of z minus 1 by 2. Okay, we'll write it on the next page. Y of z minus 1 by 2 z inverse y of z plus 1 by 4 z power minus 2 y of z is equal to w of z. Okay, ultimately we have to get y of z. So y of z is equal to 1 by 2 z inverse y of z minus minus 1 by 4 z power minus 2 y of z, then plus w of z. Okay, so that means what? Suppose if we have w of z, from that we can get y of z. Again, along with extra term, we apply the delay z inverse with the gain 1 by 2, one more delay with the gain minus 1 by 4 together. Okay, so this is the realization at the output side. Okay, now we have to combine both input and output. Again, the WZ is a temporary variable. Okay, so now we have to connect these two. So final direct form one structure by combining both input and output side, we can like x of z inverse Okay, so next the realization with the direct form 2 structure. Direct form 2 realization. What is the h of z? This is h of z. So y of z divided by x of z is equal to 1 plus z inverse divided by 1 minus 1 by 2 z inverse plus 1 by 4 z power minus 2. We know that for the direct form 2 structure, we'll be assigning the temporary variable like this, y of z divided by w of z, again multiplied with w of z divided by x of z. Okay, so just we are multiplying and dividing by w of z. Then 1 plus z inverse 1 1 plus 4 z power minus 2. Okay, then what is y of z divided by w of z? Just take the numerator 1 plus z inverse. For the second one, w of z divided by x of z, take the denominator, that is 1 minus 1 by 2 z inverse 1 plus 4 z power minus 2. Okay, so again from this we can write like y of z is equal to w of z plus z inverse w z. Again from this we can write w z minus 1 by 2 z inverse w z plus 1 by 4 z power minus 2 w z is equal to x of z. Okay, so w z is equal to x z plus 1 by 2 z power minus 1 w z plus minus 1 by 4 z power minus 2 w z. Okay, if you observe here, this is the output side function and this one is the input side function. But in both the cases, the common variable is w z. Okay, so keeping in mind, we'll realize this first. We'll realize at the input side. Okay, so we are having x of z. Okay, from the x of z, we have to get some w of z. Okay, then again along with the extra term. So I'll apply the delay here z inverse with the gain of plus 1 by 2. Then one more z inverse with the gain of minus 1 by 4. Okay, these two is added here. Again, this will be added here. Okay, finally, if you observe, this is added. Okay, finally, if you observe, wz is equal to x of z with z inverse into 1 by 2, that is 1 by 2 z inverse, and then minus 1 by 4 z power minus 2. Okay, so similarly we have to realize this also. Okay, finally we are getting y of z. Okay, say y of z is here. Okay, wz is directly there. Again wz is also delayed by the factor of 1, that is multiplied with z inverse. Okay, that I can get easily from here. Say wz is there, again multiplied with z inverse, just apply the gain factor 1. Okay, then put one more adder here. So in this process what we are getting, okay, this is wz, it is directly coming. Again wz is also multiplied with z inverse, again it's simply added, so that finally we can get y of z. Okay, so this is the direct form to realization. Again, if you observe here, the delay element is common to both input and output, whereas in case of direct form one structure, the delay element is different. Okay, again separately we are using delay element at input side, again separate delay element at the output side. Okay, that is the main difference between the direct form 1 and 2 structure. Okay, with this we will stop. Thank you.